Let us go now to the AC bridge. After understanding this DC bridge, we will go to the AC bridge. AC bridge is same as DC bridge. We are going to look for balance condition and so on, but uh, if I need to measure the value of capacitor or inductor, you know, capacitor and inductor in DC circuit, they don't have effect. Capacitor will act as open circuit and inductor will be as short circuit. That's why they are not going to have effect. For that purpose, we are going to use the excitation power supply as a AC if my elements are not resistor. If the elements of the bridge is something else like capacitor and inductor. So keep in your mind, AC bridge will be used when I want to measure a value of capacitor or inductor. I need the excitation power supply to be AC. That's why we call them AC bridge. In AC bridge, it's the same exactly as before. I'm not going to spend time here. We have Z1, Z2, Z3, and Z4. We are going to look for balance condition. Balance means the current here equal to 0. Once the current equal to 0, we are going to use the formula Z1, Z4 equal to Z2, Z3. But here, he's showing the derivation, same thing as before, same as before. So notice here the result of the derivation, he used voltage divider rule and voltage divider rule, and finally we are getting to get this condition. He said Z1 Z4 equal to Z2 Z3, or we can put it in a form or in admittance way. We can say Y1 Y4 equal to Y2 Y3. Impedance or admittance, it's the same thing, it doesn't matter. But impedance means what? What's the difference between resistance and impedance? Resistance is a value, or it's the element which having only value, which having magnitude and its angle is 0. That means there is no imaginary effect in it. But when I talk about impedance, I hope you remember the circuit or the circuit we have studied in first year, circuit analysis. You will find that the impedance is certain magnitude like X plus JY. That's the impedance. Or we can express it as a Z angle theta. That's the impedance. So when I say the conditions are to be satisfied or the balance to be satisfied, we have to keep in our mind the magnitude and the angle. Here I am showing the meaning of each element. But one thing before I proceed to the next slide, I need to remind you that the power supply must be AC here. So the balance condition, as you see here, is expressed as magnitude and angle till the end. So Z1 theta 1 into Z4 theta 4 equal to Z2 theta 2 into Z3 theta 3. Or we can write it as Z1 Z4 angle theta 1 plus theta 4 equal to Z4 Z2 Z3 angle theta 2 plus theta 3. This telling us that, because you see here, this quantity is supposed to be equal to this quantity. That means the condition to be obtained, we need to satisfy two conditions. Z1, Z4 equal to Z2, Z3. That means here we are dealing with magnitudes. And in the same time, we are supposed to satisfy this, which the angles theta 1 plus theta 4 equal to theta 2 plus theta 3. This is just to remind you in dealing with the complex quantity. So what is the complex quantity, which you have studied it before? You can look at it anyway. This is something we have studied earlier. Let's see this example. In this example, he's saying the impedance of a basic AC bridge are given as follow. We are having basic AC bridge as seen earlier. Z1 equal to 100 angle 80. That means it's inductive, means resistor with inductor. So Z1 is something like this, inductor, resistor with inductor. Now Z2 equal to 250 ohm. That means Z2 is only resistor. Z3 is 400 angle 30. Z3 is 400 angle 30. That means it's inductor. So it's a resistor with inductor. How do I know this? Because here the angle is positive, it means it's inductor. Angle is positive, it means it's inductor. Okay, inductor with resistor, I mean. The question is asking us to calculate Z4, which is the unknown value. So by calculation from the formulas in the previous slide, Z4 is calculated from this formula, and finally we will find that it's 1 kilo ohm. Very good. It's 1 kilo ohm. But is it only 1 kilo ohm or 1 angle something? Remember, it's AC bridge. That means we have to consider the angles as well. So from here we can get the angles. For in balance condition, we said theta 4 plus theta 1 equal to theta 2 plus theta 3. Or we can write it as you see here. Theta 4 is equal to theta 2 plus theta 3 minus theta 1. So calculate it, you are going to find that theta 4 equal to minus 50 degrees Celsius, minus 50 degree. If it's minus 50 degree, that means Z4 can be written as 1000 angle minus 50. 1000 angle minus 50, which means it's element with capacitive effect. Since the angle is negative, that means this element is something like resistor with capacitor. Okay, after discussing the bridges, the AC and DC bridges, it's the time now to talk about data acquisition system. Wherein data acquisition system or data acquisition means collecting the electrical signal and send it to the computer. The process of collecting the electrical signal and send it to the computer called data acquisition. Now, what is data acquisition system? It's the system which will do this job. The system which going to be connected between the measured quantity and the computer. We call it data acquisition system. After a while, we are going to go to the detail. But why do I need to get this data acquisition system? In instrumentation, usually we are measuring a signal, which physical signal. We are measuring temperature, measuring speed, measuring pressure, measuring acceleration, or any elements to be measured, any variable to be measured. We are measuring the variable, and we are going to get at the sensor output analog signal proportional to it. So this signal is going to be sent to the computer for processing. What is the stages, or how am I going to get that signal to the stages? It's through what is called data acquisition system. Let us see here what is the part of data acquisition system. Remember here, I'm going to go to the detail of the system, not like what I mentioned earlier. Earlier, I'm talking about the typical instrumentation system, means in general what I'm going to find. Here, I'm going to go to the detail. The importance of data acquisition system reduces the cost. Maybe somebody will think how it's going to reduce the cost, because I don't need an operator to deal with it. I'm just connecting the sensor to the computer through the data acquisition system, and data is going to transfer automatically. The accuracy is going to be higher since I'm dealing with computer, and the measurement will be faster, a quick measurement. As I mentioned, it depends on the instruments I am using. So it's electrical signal, so the measurement will be very fast. Data transmission will be fast because sometimes I need to measure and send data to somewhere else. So when I put the data in digital form or in electrical form, I can transmit it from location to even different location, far from the first one. We can get the data to the computer. We can put the data in a form which is suitable for computer, so we can keep it in the computer for processing or saving. So the component of data acquisition system is the sensor, or are the sensors. We know what the sensors, we discussed it earlier. Signal conditioning circuitry, we are going to have we are going to have signal conditioning. Here, signal conditioning means putting the signal in its better form. We are going to clean the signal before the next stage. You will see when we come to the signal conditioning. Here, actually, we are going to study the parts one by one. We are going to study them in detail. Only sensor, we are going to postpone it a little bit, but the other elements we are going to study in the following weeks. Analog to digital converter, which convert the analog to digital, we discussed it earlier. Beside analog to digital converter, we need to get the signal, we need to convert the signal. So I need transducer sometimes, because I need to get the signal from its physical form to electrical form. We said the transducer is converting from form to other form, not electrical. So sometimes in my measurement, I need a transducer to convert the signal from its physical form to other physical form. Then I will use the sensor to convert it from the new physical form to electrical form. So a transducer is needed sometimes. Amplifier also needed sometimes. Filter is needed. Analog multiplexer, sample and hold, or analog to digital converter parts. If I look at the system of data acquisition system, what is it? You will find that it's transducer. Remember, transducer here, I mean it's the sensors, because sensor is coming sometimes under transducer, so we can call it transducer. But keep in your mind that here the signal is supposed to be electrical always, so it's a sensor. Then amplifier, then active filter, then we will go to analog multiplexer. Multiplexer, let me tell you its function here, because we are not going to study it in detail or after this. Multiplexer is accepting many signal, as you see here, not only this, many other signal, and it's going to produce on the output only one output. So multiplexer is going to mix those signal to the following stage. Takes the signal, the inputs from many locations, and sending them through one channel to the next stage, which sample and hold. Sample and hold, it's sampling the signal as a preparation for analog to digital converter. Then we will be able to send it to the computer. The process which you can see here, if I will go to the modern kind of system, you are going to find that it's to be done through program. So we need a program sequencer which going to send signal to the locations to synchronize the process, synchronize the operation, which going to take signal from control. Control means from a computer or from operator, it depends. Transducer, so it's as I said, this is discussed earlier, actually no need to repeat it again. As the signal which we need to measure, we need to convert it to a form which to be electrical by the end of the day. So I said this transducer is general form, but we are going to use sensors in this, as a one part of transducers. Amplifier, as we agreed earlier, also amplifier is to amplify the signal, and very soon in the following week we are going to study the detailed amplifier. Active filter is removing the noise from the signal measured, and multiplexer, I discussed it just now, it's just joining the signals. Sample and hold, it's to convert the signal from its analog to discrete values proportional to the analog signal as a preparation for the analog to digital converter. It's coming in the coming weeks. And then computer or data bus means the data now is ready to go inside the computer, or what we call it here, it's going to flow through the data bus. So the operation of data acquisition system is going to be done through a program sequencer, which will send the instructions or the signals to the part of the data acquisition system to operate in a synchronized way. That's all about this week material. Hopefully in the next week we will be able to start dealing with this data acquisition system part by part. So we will go to the amplifier, we will go to the analog digital converter to get a clear picture of data acquisition system. I wish you all the best. Thank you very much.